This is Professor Howard, and welcome to Tutorial B, Mapping Historic Census Data with QGIS. The resources for this tutorial are available on our course Blackboard page or on my website, ellakehoward.com, Mapping Historic Census Data with QGIS, under Digital Projects. In this tutorial, we are preparing for Lab 2, where you'll be mapping your own census data. So to do this, you want to practice gathering your CSV files and your shape files, manipulating your data, doing some calculations, and then importing that data into QGIS software, creating and styling a map. The files that you'll be using for this are census files that I have already downloaded off of the NHGIS website for 1940 and 1980. I've shared these files with the class through our Wentworth OneDrive platform. So if you go into your OneDrive, you should be one of the people who has access to a folder called 1940 and 1980 census data. Inside, you'll see these two packets, directories for each of those dates, and inside there you'll have your CSV and your shape files. So the easiest way to download this is clicking the button next to 1940 and then choosing Download. That will bring the folder as a zip file into your downloads area. Once you've dragged it from your downloads to your desktop, then you're going to want to extract your data. And that will take some time because you have to extract all of the different levels of the folder. So if we go up a level, you'll see it was originally zipped inside of many layers inside of each other. So inside the 1940 area, I had to unzip the CSV and the shapefile. And then inside the CSV, you want to make sure you unzip everything so that you can get to the point where you can see the actual little Excel logos. So this was several layers of unzipping and extracting files. Inside the shapefile folder, you can see I had to also unzip inside there to the point where you get all of these file names. So you want to be sure that you don't see any more options here that say extract all. That's how you know that you've done it. When you can click all the way around and you don't see through the various file levels and you don't see the option extract all anymore, you know you've finally done it. And it really does take several different efforts. But once you've done that, the next step is going to be to manipulate your data. So to do that, you want to open the data that I was just looking at. We're going to go into the CSV file. That's where our data is for this. And what I've done is I've created a new version. So I did this by opening up this tract file. And you'll notice in here that you've got your GIS join, the year of the census, the state name. Each state apparently has a unique number. Each county has a name and a number. So 73 is the code for Jefferson County in Alabama. Each census tract, which is a subdivision of the county, also has a number, and that's going to have specific shapefiles and boundaries. Then we also have demographic data. In this case, white and non-white residents of each census tract. So this is a huge data table that covers the entire country, the United States in 1940, for all those areas that were mapped at the tract level. So that'll only be somewhat urban environments. They weren't conducting this level of low-level micro-analysis for rural areas. So now what you want to do is you're going to create a column here where you're going to do the math for your calculations. So I called mine PNW for % non-white. I typed a descriptor here, following the conventions of the other fields, and then calculated that here. With an equal sign, always in Excel when we start a formula, we do it with equals. And to calculate % non-white residents would be non-white over the total, and the total would be white plus non-white. Close parentheses and hit return. This does the calculation, and then you want to double click on the little box in the corner of the cell to apply that all the way down. So now we see this displayed in this format, and we're going to want to format cells to get some control over the decimal places. So if you format it as a number, you can choose 2 decimal places and that'll work. You don't want to format it as a % because if you do that and you format it as a %, it's going to display with a % sign at the end. And anything that has a percent sign at the end is no longer an integer. It's now a string of text. Don't ask me how I learned this. I learned it the hard way. So just take my advice and call it a number and then save it in that format. When you've done that and said OK, then you're going to want to save this file, making sure that you save it as a CSV file, not an Excel spreadsheet. It has to be a comma-separated value folder file. And then you're going to, also when you do that, I suggest, and this is optional, but I suggest changing the file name in some way so that you'll know this is the version of this file where you did your math. And I suggest that because if you want to use this file later to do a different type of calculation, you may want to preserve a clean version of the file as you downloaded it. So in my case, I made my new version of this when I saved it as calc at the end of the name, tracked calc, for calculation, and save this as a CSV file, comma delimited. When you've done that, it should appear here, your new version. And the tracked codebook is that little text file that gives you some information about what the fields are in your census data. So once you've done that, now we're ready to go ahead and import that data to QGIS. So we can first import our shapefile by creating a vector layer and downloading the, browsing to the shapefile itself. So that'll be up in the shapefiles area. We can get inside here and choose the one with the SHP file extension. Add. Oops, added it twice. Didn't mean to do that. I'll just remove one. Sorry. Now we want to add our data table. We're going to add that as a delimited text layer. And again, don't always listen to what it's prompting you to do. You have to always stay alert in QGIS and be mindful of the data that you're really looking for. So here, of course, we want our newly modified calculated file. It's going to come in as CSV with no geometry. The first record does have field names, and we can preview it here to see how that's coming in. At first we might panic because it might look like these are null values, but they're not, because when you scroll down you'll see there's actual data there, and that's what you want to see. If you had done this with a percent, it will come out as null. It'll say the word null. So now say add and close. We've brought this data in, but it hasn't been joined yet. So before we join it, we don't want to join it yet, we want to take a look at the attribute table. So now we can look at it on the inside. We see that it's imported as those values, but we still have a problem. The problem is that even after all of our hard work manipulating our data and calculating our calculations, when we hover over the title, right, that top field header for that column, you see that it says text. And that's a problem because it means that it's not seeing this as a number. So the easiest way to correct this is to manipulate the data here inside this view. So to manipulate this data, we want to go ahead and close our attribute table and join it to our track layer. So under joins, we will add that calculated data table on the GIS join field, as we've been doing. Apply and say OK. Now that you've joined your data table to your shapefile, when you open the attribute table for the shapefile, and we see this big long data table, find that column, here it is, right? We recognize these numbers. This is our calculated percent non-white, and you see here it's come in as a text file as we anticipated. So what we want to do is we want to edit that, and the trick is you have to edit it after you join it in this situation. So otherwise you're not able to create a real layer. You can only create a virtual layer. So here we're going to click on the abacus of your virtual field, sorry. Click on that abacus, the small counting toy you may have had when you were a kid. And now it gives us the option to create a new field. To do that, we give the name for the column. So here I'm going to call it PNW map, since this is the data that I'm mapping. And this gives us the option to choose decimal number real. You can edit according to your own mathematical preferences, what it is that you're doing here, the level of precision you want to give to this. But the trick is that you have to double click on fields and values, find that exact calculation, PNW. So what we're doing then is we are replicating the column with our calculation, which is a text field. We're making a new column that's going to just copy over that old information, but now it's going to be a number. Right? So 4, instead of being a text, will now be a number, for instance. So just double click on that calculated field, whatever you called it, and it'll appear here in your expression editor. And that's all you have to do. Say OK. That's going to make some changes to our file. So now we have another field that looks exactly the same as this old field, really, but when you hover over this one, it has a different category, right? So it doesn't say text like this one does. So now, when you close this, that will automatically save it, and we can go ahead and make some progress on our map. So we've joined them together, right? You can see our join here, and under symbology, you can opt now for graduated, and it will see our PNW map as a calculation, as an integer field, so it knows that that's data that it can map quantitatively. When we classify our data, if you opt for natural breaks, you'll see some numbers. And you can opt for however many classes of data you want. You can choose your color ramp. If there's a color ramp that makes more sense to you, something that you like to see. That one's kind of hideous, but I'll use it for now. Then you say apply. And only when you say apply and OK, then do you get to start to see some data, because there was nothing to display before. Because this is not a map of the United States in the traditional sense, this is the boundary files just for census districts. So now when I zoom in on a particular area, I can see it lights up in different, albeit quite ugly colors because of the color ramp that I chose, but what we're looking at here are distinctions that indicate % non-white residents. So your final steps in this process are going to be to export your map as a PDF for saving or submitting. And to do that, you want to choose Project, New, Print Layout. Now you have to give it a title. Every time you create an export out of the software, even to print or generate a PDF, you have to give it a title first. It's extremely counterintuitive. But I'll say Print 1, I'm calling this. Now it looks as if everything's gone wrong, but by now you know enough to know that that means everything's going really well, right? So in GIS, your next step is to click on Add Item, Add Map, and now draw a box with the cursor that you've been given. Now it renders your map inside. You can manipulate the map as you will. You can drag it around, zoom in until you have it in the format that you want to use. You've got some tools over here you can explore, the dragging hand, zooms, etc. The other features that you're using for this are going to be Add Label, Add Scale Ruler, Add Legend. So for those, when you add a label, for instance, it's really giving you the text box icon so that you can drag a text box and put a title in. When you're done with this and you've added all of the things in the tutorial, then you use the Layout menu to export as PDF. So export as PDF, save that file carefully, and those are the pieces you'll be submitting. Hopefully your map will look better than mine, but we've reached the end of our tutorial here for class. If you have any questions, please don't hesitate to ask. Thank you very much, and I hope you're enjoying our journey through QGIS.